In the Hawkesbury River, north of Sydney, something sinister is in the water. Unseen, indiscriminate. A killer disease that with frightening regularity wipes out entire harvests of oysters. This group of scientists is hunting it. Oyster grower John Stubbs takes us to a lease close to the river mouth, where disease predictably strikes first. For John, this is personal. His lease was first hit in 2013.
It wiped us out. Like in Mullet Creek, it killed 10 million oysters overnight.
Overnight?
Yeah, overnight. It was devastating. The actual lease, it was like a cloudy formation throughout the lease of mortality. One basket would be no dead, a few dead over in the other line next to it. Across the creek, no one was dead. But the next morning, the whole creek was dead. It was, incredible.
And what did that do to your business?
Oh, overnight, it was gone.
Pacific oyster mortality syndrome is a herpes virus that is carried in the clouds of plankton the oysters feed on. It's a problem that seems linked to warmer ocean temperatures, predictably striking here in late spring or early summer, but it goes far beyond the Hawkesbury.
There were explosive outbreaks in France and then subsequently right around Europe, so the entire Atlantic coastline, the Mediterranean and so on, right up into Scandinavia now.
Richard Whittington has been studying oyster diseases for over a decade.
We're going to subdivide into 3 categories. Dead with meat, nice and fresh. Yeah. Dead and empty when there's no meat left. And then something in the middle.
Richard and 2 research students are helping with Francisca Samsing's project.
So we're taking out the baskets and we're counting to see whether there is any mortality. So Armand's getting the baskets out of the water. We empty the basket and just basically count, dead and alive.
The scientists can hear these oysters are healthy. They rattle on the boat deck, heavy with water and sealed tightly shut by the live mollusk. A few kilometres upstream, Francisca finds what she's looking for. Baskets full of empty shells. Something has killed the oysters.
We have found roughly 60% mortality, so we're taking these back to the lab to see what might be going on with these animals.
It had seemed that there was little growers could do, other than harvest early before the water got too warm.
Because oysters are considered to be primitive animals that don't have an immune system like ours, and it could not possibly respond to a vaccine. That was the dogma.
But all this painstaking field work led to a hunch. The researchers noticed some oysters survived year after year.
We were convinced that there was natural immunity developing in animals that had been exposed to this virus, particularly during cooler months of the year.
And that theory has led to a breakthrough. Fran and her team have developed a vaccine.
It was very surprising to see it in front of your eyes. So basically you're putting a live virus into an animal and it's surviving to the challenge. And my PhD student Armand, he's been working on this project and he came to my office very excited, said, it's working. It is exciting. Yes, we're getting a survival between 86 and 93% survival.
This project builds on Richard's work.
It's a technological breakthrough which opens up the possibility of a new industrial process that in any other farming system with animals we would call vaccination.
Vaccinating oysters one at a time is impractical and prohibitively expensive. The next step is working out how to deliver the vaccine at scale.
You could attach this vaccine to the feed of the oysters, which are just algae. So you could coat your algae, you could simply put it in the water.
The vaccine works against Pacific oyster mortality syndrome, or POMS.
Knowing that injection works for this particular disease sets a precedent for what can be done in the future for other diseases. The other disease that affects Sydney rock oysters, QX disease, It's a different kind of agent, so it's a parasite. Vaccines for parasites are more challenging, but that doesn't mean that it's something that could be explored in the future.
Like other growers in the Hawkesbury, John Stubbs can't grow Pacific oysters anymore because of the POMS virus. He pulled out his crop of Sydney rock oysters before Christmas, before it could be infected by the other major killer of oysters, called QX disease.
But the methodology that they'll probably be developing in that process could potentially lead to a vaccine against QX, and that would be a big game changer for New South Wales, that's for sure.
All this talk of oyster mortality and herpes can be a little, well, unpalatable. But it's important to remember that while these viruses are devastating to the industry and to oysters, they're mollusk viruses. They can't hurt people. Amazing.